Alright, so we are in the second video for week 5, and last time we talked about this idea of a moving frame, and we're still working with that idea, and we're wanting to use those vectors of reference to talk about a point as it moves along a path. And we also saw in the last video, well, actually previously we already learned about this vector t. We also, in the last video, talked about n, and well, now we're going to talk about that vector b. So to get a third vector, we might remember that if we want to find a third vector that's perpendicular to the two existing vectors that we have, we find it by a cross product. So all we have to do to find the unit binormal vector, okay, that's the name for b, is by taking a cross product, okay? And it does have to be in this order. It is not equal to n cross t, okay? If you want to think of this as like your x, because that's kind of in the direction of motion, and then this isn't your y, well, then this is going to be in your z, okay? That sort of thing. The order is well defined here. Okay, so if we just were to draw the diagram, and remember we're looking at that path. Okay, so let's see, we have something like this, okay, and now here's our point x on the curve. Let me undo that, try that again. Okay, then we have the unit tangent here, we have the unit normal vector here, and then we're going to have the unit binormal in that third dimension. Okay, and these are all, so this is t, and then n, and then we have b. Okay, all mutually orthogonal. Okay, and so this video is actually going to be kind of short because normally after this we would go through an example or 5, and they take a long time, and they can be really messy. Okay, so you kind of have the framework to do these. It's a lot of derivatives and a lot of magnitudes, all that good stuff. One suggestion that I have is that if you're looking for the frame at one point, let's say t is equal to t naught, then why not make your life easy? Like, don't do more work. Okay, so for example, if you're given, okay, so you're maybe given t is equal to t naught, and then you're also given a path x. Well, from path x you can get the derivative of that path, and then, well, from that means you can get the unit tangent vector. Okay, and you can compute then the unit tangent vector at that point, which is what you need, right? Okay. Similarly, okay, with the unit tangent vector, you can come down here and take its derivative. Yeah? Okay. Well, then you can get the unit tangent vector derivative at t naught. Okay, and then from here you can find the length, right, of the derivative of the unit tangent vector at that point, which then you can use to find your normal vector, or your unit normal vector at that point, and then finally use these two in conjunction via a cross product to get your unit binormal vector at t naught. Oftentimes these calculations, after you've plugged in your particular value of t, are a little bit easier to work with rather than doing like sines, cosines, all that good stuff, and proceeding that way. Okay. Otherwise, at this point, this is one point where I would actually recommend to check your derivatives, all that stuff with Wolfram Alpha, because if you mess up, say like at the unit tangent vector, well, then everything else is fruit of a bad tree, so that's a very bad thing. Okay, so just be mindful of all that, and be careful when you're doing your calculations with these things. Stay tuned for more information on some properties related to T, N, and B.